You are literally killing the soul of your coffee every single time you hit that 30-second button on your microwave. Most people think they are just adding heat back into a cold mug, but science shows you are actually triggering a chemical disaster. We have all been there. You brew a perfect cup, get distracted by an email or a phone call, and 20 minutes later, your drink is lukewarm. Instead of pouring it out, you toss it in the microwave, but it never tastes the same once it comes back out. Why does it suddenly turn bitter, sour, and smell like burnt rubber after just a few seconds of radiation? Today, we are uncovering the hidden science of why your microwave is a coffee assassin and what is actually happening inside that mug. To understand this, we have to look at how microwaves actually function compared to a traditional stove or a kettle. A microwave uses radio waves to vibrate water molecules inside your mug at an insane speed. This friction creates heat, but it does not heat things evenly from the outside in like a normal oven does. Instead, it creates random hotspots throughout the liquid, which is the first step toward ruining your drink forever. Coffee is not just brown water. It is actually a complex soup of over 1,000 different aromatic compounds and delicate oils. When coffee cools down, these chemical structures begin to change through a process called oxidation. When you introduce sudden, uneven heat from a microwave, you force these delicate compounds to break down even faster. One of the biggest culprits in this flavor tragedy is a specific substance called chlorogenic acid. As that acid breaks down under the intense radiation, it turns into something called quinic acid. This is the exact chemical responsible for that nasty, astringent, and metallic taste that lingers on your tongue after a bad sip. Essentially, you are not just reheating the liquid, you are chemically recooking the beans into something entirely different and much less pleasant than what you started with. Think about the wonderful smell of a fresh brew in the morning. Those are the volatile oils escaping into the air, which is why your kitchen smells like a high-end cafe. When you microwave that cup, those remaining oils get zapped and evaporated almost instantly. You are left with a liquid that has all the caffeine, but absolutely none of the flavor profile you originally paid for. Researchers have found that coffee flavor is at its peak when the brewing water is between 195 and 205 degrees Fahrenheit. Once the brewed coffee drops below 140 degrees, the chemical party starts to die. Reheating it might bring the temperature back up, but it cannot bring the dead flavors back to life. It is like trying to turn a hard-boiled egg back into a raw one. The chemistry has already changed. There is also a physical danger you might not know about called superheating. Sometimes the water in your coffee can get hotter than the boiling point without actually showing any bubbles. The moment you move the mug or drop a sugar cube in, the liquid can violently erupt and cause serious burns to your hands or face. This happens because the microwave heats the liquid so fast that steam bubbles cannot form properly. Have you ever noticed that the top layer of your microwaved coffee feels like lava while the bottom is still cold? That temperature imbalance creates a weird sensation where your taste buds are scorched while also detecting stale flavors. This is why professional baristas will almost never tell you to put a cup in the microwave. If you really hate wasting coffee, there are much better ways to save your morning caffeine fix. You could try adding a tiny splash of boiling water to a concentrated cold brew or using a dedicated mug warmer. A mug warmer provides a gentle, consistent heat that does not cause the same aggressive chemical breakdown. Or, if the coffee has gone totally cold, you could just embrace the temperature change and turn it into an iced coffee with a few cubes. Your microwave is great for leftovers, but it is the enemy of a high-quality Arabica bean. By understanding the chemistry of quinic acid and the physics of molecular friction, you can finally stop wondering why your coffee tastes like battery acid. Life is too short to drink chemically altered, bitter coffee that has been zapped into submission by radio waves. If you want to see how to brew the perfect cup that stays hot for hours, click the video on the screen right now.